Hi, welcome to product review by watthour. In this video we are going to do the review and test of this TC4056 one-cell lithium battery charger with battery protection. I'm going to explain the module, the components one by one, and we will look at the data sheet. Then I'm going to show the schematic, how it operates. After that I'm going to show you the wiring. Then we are going to test it by connecting a battery to charge it. Then I'm going to measure the input current at the input side and the charge current, and also we are going to connect a load and measure the current from the load. I'm going to test the output short circuit protection. Then we are going to test the overcurrent protection to see how much current it allows from the battery to be drained. Also, I'm going to use thermal camera to show which spot is getting hot the most. You can get the resources for this video by visiting our website watthour.ca. This is our module. We will connect USB connector here. This is a micro USB, and the 5 volts will enter here. This is a chip TC4056, and it is offered as micro USB and also USB-C version, so you can buy it. And then we have two other chips here. This is a MOSFET driver, that's a lithium battery protection. Amount of current that the chip provides is 1 ampere. After this, we have two terminals here. We will connect the battery to these two terminals, and our load, light, whatever you have, you can power it up from this. This will protect the battery when the voltage drops or amount of current. So this is very useful in that case. And here we have two LEDs here. One is for power on and the other one is for charge. We can either connect via USB or we can connect our wire if we have 5 volts directly here. But here you can connect up to 8 volts. So this chip can handle up to 8 volts at the input. That does not let the battery to be drained by the load. So you will connect your load at these two other pins, and this controller chip will control it and will protect your battery. This will protect your battery for under voltage protection. Let's have a look at some of the data from the manufacturer. I hope this is the correct data from manufacturer, because you cannot find even the manufacturer, and multiple people are just copying the same product and producing it. Input voltage here it says 4.5 to 5 volts, 5.5 volts. That is for the USB, but if you want to connect directly, you can connect up to 8 volts. Full charge voltage 4.2. Battery discharge termination voltage 3.2, which I will look at the chip. Current protection is the most important one, so it will not allow above 3 ampere, which I'm going to test it. If you got this module which does not have the protection, everything else that I've shown you will work exactly the same, because the chip is the same. So you will just connect your battery and you will charge without the protection, and it will work, and the specification is the same. Or you might see it something like this, black without the protection. It has the same battery terminals and inputs. The same chip is used, so you can use this one as well. The only difference is that this does not have the battery protection. And if you want to increase the amount of current, and for some reason you don't have another charger, you can, if you have multiple of these, you can do so by connecting them like this. So if you connect 2 of these, it will be 2 ampere for charge, and if you put 3, it will be 3, and so forth. So each will add 1 ampere. And here is how you connect them. You will connect your battery from positive to this positive, and B minus to B minus, and then the out plus to out plus, and negative out negative to out negative. So this side is done, and because you will have only 1 wire for the battery, 1 pair for the battery, and 1 pair for the load, then you will connect it. Here on this side, you connect one USB here and the other USB here, and each will draw separate power to output. But if you do not want to use USB, then you can connect them like this. This input positive to the positive, negative to the negative, and then one pair of wires will go and will be connected to power supply, which can supply enough current. If you're connecting two of this, make sure it supplies at least 2 ampere, and if you're connecting 3 in parallel like this, so then you will have 3 ampere power at the input up to 8 volts. Now let me show you the components under the digital magnifier. TC4056, and this has been also mentioned as TP4056. This is the main charger controller, and here is a data sheet for TC4056, the main chip linear charger. The fixed charge voltage is 4.2 volts, so it will stop at 4.2. When AC or power adapter is disconnected, it needs only 2 microampere to keep the module running. So 1000 milliampere programmable charge. This is a trickle charge when the battery is charged and later on continuously not used. So at 2.9 it will send some current to check it. And also soft start in rush current when the battery is fully drained. At the beginning it needs a lot of current, so this will not allow it. Input supply is from minus 0.3, which means up to 8 volts can be connected. So we can select the R, and here for 1000 milliampere you need 1.2 kilo ohm resistor, and it says plus minus 10% error. This dot means pin 1, pin 2, and that is the program pin. As you can see, it is 1, 2, 2. The last 2 means 20, 1200. That's why it is set to maximum current. This is a program resistor. If you want to change and control the current, we will replace this. This chip is 8205. Here's a data sheet for 8025A. This is dual N-channel enhancement mode MOSFET. And we have 2 MOSFET inside this package where the gate is being controlled. So the drain and source is being used for the connection. As you can see here, this middle pin is the source 2, and that's source 1. So this middle one. And the next chip here is DW01A, and this is the DW01A. This is a battery protection IC, and this has 3 important pins that does the job. One is the current sensing CS, overcurrent pin, and over discharge. These 2 pins are controlling external gate of a MOSFET, and this is detecting the voltage between this point, which is connected to the load, and this point that is connected to the negative of the battery. And here's the basic schematic for the chip 4056. We have an input of 4.5 to 8 volts. In our case, if it is USB, it will be connected with 5 volts. Otherwise, you can connect up to 8 volts at the input. And these 2 terminals are for the output, where you can connect it to your battery. All the pins have been labeled. This is charge pin. When the charge happens or the battery is charged, this LED will turn on. So this go low, and from here the 5 volts will pass through this 1 kilo ohm resistor, and this LED will turn on. And when it is in standby mode and not charging, then this pin will go low or becomes 0, so the blue will be turned on. This pin is temperature control, which has not been used in this module, in this PCB that we got. And this is the program pin, where we use 1.2 kilo ohm resistor to allow 1 ampere current. So this is the basic configuration, where you can just use the chip with these simple components to charge lithium battery without protection. And here is a full schematic of the module with the protection. So this portion I've just explained it. As you can see, this is connecting, the output pin is connected directly to the load, and it is connected to the battery. So we have 1 pin, but the negative here, it goes directly to the load, but not to the battery, because we want to connect the battery. So here is how it functions. This protection chip is used with a chip that has two MOSFETs in one package. This is monitoring the voltage of the battery and then determining if it should be connected or not. So this negative to the battery should be connected or not. And here is the schematic that I found online for this module with the 4056. They put as TP, but most of the chips that I've seen are TC. Doesn't matter because this 4056 is this charger, and here is a USB connector, the external power, which is connected to pin 1 and pin 5. And then these are the output terminal. The two are for the battery. These two last one is for the load. And this is DW01, which controls the FS82501. And as you can see here, this is now connected only to one of the gates. Not two gates are connected here. And here this is another schematic, which is the same thing except it's drawn a little bold so you can see it. I'll provide you this one within the resources page for this video. The link is below the video in the description. Now let's check if over discharge protection and overcurrent protection, both of these are used in our module. So over discharge protection from pin 1 is supposed to be connected to pin 4 of this chip, 8205A, and from pin 3 will be connected to pin 5. And here, this is our DW01, and this dot here represents pin 1. So we have pin 2, pin 3. Pin 1 is supposed to be connected to pin 4 of this, and we have a dot here. So pin 1, 2, 3, and that's 4. So pin 1 is indeed connected to pin 4. And we know now over discharge protection is used in our module. And then now let's see over current protection. If it has been configured from pin 3 to pin 5, there must be a connection. So here pin 1, 2, and then 3. Pin 3 is connected to this pass-through hole, and it's supposed to be connected to pin 5 here. That because this is pin 1, 2, 3, and 4, and it comes here 5 up to 8. So this is pin 5 at this corner. See this hole, if it is close to this on the other side where it goes. So this is the hole close to this. From here it goes directly in front of this, further away, in front of the second hole. So this is, let me just turn it. So it is in front of this, somewhere here. And we can use continuity tester or multimeter to see if this pin is connected indeed to this pin. And here I've set my multimeter in continuity mode. When I connect this, it buzzes. Now let's see if this pin is connected to this first pin. Indeed, it is connected. So overcurrent protection is also enabled in this module. Current protection for one cell lithium battery. And here are the pins. This is for over discharge protection. This is current sensing for overcurrent protection, and this is for overcharge protection. And here are the values for overcharge protection. Is at 4.3 volts. That is the start of the overcharge protection. When the voltage goes down back to 4.1, it will release it. And over discharge protection is a function that does not allow, for example, in this case, the voltage to go below 2.4 volts, and it will keep it off until the battery is charged. The level of the voltage increases. At 3 volts, the overcharge protection will be turned off, so the battery can be used. And then we have overcurrent protection pin that receives 150 millivolts to react. And here the short circuit protection is activated at 1.2 volts. Overcharge protection has 40 millisecond delay. In case if something happens, it will not react within 80 milliseconds, but the maximum is 200 milliseconds. Over discharge delay is 40 milliseconds, and over current is also 10 milliseconds. Let me explain now the protection. First, we have to know how the charge happens. So this is the path of the charger. The positive goes through the chip directly to the battery, and the negative goes through this 8205A MOSFETs and reaches to the negative terminal, and the battery is being charged. And when we talk about overcharge protection, then the voltage of the battery from positive and this side is negative, so it is being monitored continuously. And when it reaches 4.3 volts, it will turn off this MOSFET and the current cannot reach the battery because this MOSFET is off the pin 3. And now let's see how over discharge protection works. When we talk about discharge, the battery is connected to the load, the positive is connected this way, and the passes through this 8205A chip to MOSFETs, and this is the path. And it continuously checks the voltage of the battery here. In this case, the voltage to go below 2.4 volts, and it will keep it off until the battery is charged, goes down. Then the over discharge protection will turn off this pin 1. As a result, this MOSFET will be turned off, and as you can see, the path is not complete, the circuit is not complete, so the battery will be protected through this. And if the charger is working, the charge will continue pouring current on the battery, so the battery is filled up and the level of the voltage increases. At 3 volts, the overcharge protection will be turned off. When it reaches back, it will turn on again like this. Now we have overcurrent protection. Overcurrent protection is when you draw more than certain value, in this case 3 amperes from the battery. So the positive is connected from the battery to the load, and the negative also passes exactly the same as before, except this time it's being monitored via pin 2. This is CS pin or current sensing pin, which continuously checks the voltage at this point with comparing to this point, which is connected here to pin 6, the ground pin. And when the voltage reaches about 150 millivolts, it knows that the amount of current is above 3 ampere, and it will turn off this MOSFET. And as you can see, the positive is completed, the negative, the circuit is not completed because this switch is off, and the battery will be protected this way. Now let me demonstrate the short circuit protection for the output and see what happens. These are the 2 terminals for the output for the battery, and we can just short circuit it. As you can see, it shows that there is a current going and charging because this is now short circuit, and it can continuously handle the short circuit in case if you short circuit the battery. Not this section, because this is with a protection section. This is just for the battery. Now let me demonstrate the overcurrent protection. Currently the battery is not connected, the 2 terminals that are for the battery, they are just here. I'm leaving them. And for the load, I have connected these 2 terminals, the top and the bottom. These are connected to my electronic load. I'm connecting my battery terminals, so negative and positive. And as you can see, the voltage of the battery is now shown here. Let me connect 1 ampere and turn it on. So now 1 ampere is being drained from the battery, and this light was always on. That does not matter, just powered up to have control. Now the protection says that it should protect it against 3 ampere. Let me now increase it with 2 ampere, so it is protecting it. And now let me increase it 3 ampere, and as you can see, it is allowing 3 ampere. Let me go for 4 ampere because the protection is supposed to be set at 3 ampere. Let's see if it is true. So I turned it to 4 ampere. Let's see. Yes, it turned off the output, which means the current is not being allowed to go from this battery. So if I go back to 3 ampere, turn it off, because the chip needs to be turned off and turned on. It allows 3 ampere. Let me go 3.1 and see. So 3.1 is allowed, 3.2 is allowed, 3.3 is allowed, 3.4, let's give it a little time. So it is allowing the chip, the system is allowing 3.3, 3.4 to be drained from the battery, and now it's 3.5. Both of these are heating up, and as you can see, it was turned off. So if I reduce it back, so 3.4, the link for this is below the video in the description. Let me show you the thermal image to see. Now the chip is 76 degrees Celsius. The main chip is very hot at this point. Up to 3.4 and turned it off. Thermal image before it turns off, it shows 76 degrees Celsius. And now let me show you the efficiency. This is the input current to the module. The output current when the charge starts will be displayed here. And as you can see, it's all just 1 milliampere. And I'm connecting now my multimeter here. And now input is 920 milliampere at 5 volts, and output is 3.9 times this. Efficiency, when you calculate it, is 78.7%. Around 23% of energy is being wasted here. You can calculate, this is 5 volts times this will give you the power, and we have this voltage of the battery times the current will give you the power, the watt. So divide the output power by the input, you will get the efficiency multiplied by 100. And efficiency is now 75% with these currents. Thank you for watching a video from Watt Hour. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this video, we are going to see how we can use this 3-cell labeled as 40 ampere lithium battery charger. These are all exactly the same with different shapes and different manufacturer. We're going to connect it to 3 18650 lithium batteries. Then I'm going to explain the module, all the inputs and outputs. Then I'm going to look at each component and try to bring up the data sheet. After that, I'm going to explain how to prepare the batteries and connect them together. Then I'm going to solder the BMS to the battery. After that, I'm going to measure the voltages across each cell to charge it. What type of source you need. So I've set the current to 2 ampere here. Then we are going to apply charge to the batteries at different currents and check it. After that, I'm going to try to connect a load and discharge the battery and see how it behaves. I will also test the overcurrent protection, overvoltage protection, and undervoltage protection as well. And then we are going to do the short circuit protection by connecting the output of the battery short circuited.